Morning, everyone. Welcome to the next instalment of Engineering Insights. There's a Q&A session at the end of this talk. So there's a Q&A section at the bottom of your screen, but please feel free to add to the chat as well if you'd like to. So either in the chat or in the Q&A, and we'll try and get to your questions at the end. So add them anytime, whenever something comes up that you feel like you need to ask, and please do. This session will be recorded, so I know some people have to drop off sometimes. So if you go to bjss.com/Sheffield, we'll hopefully get the recording up as soon as possible for you. And you can see the other events that we're hosting for Sheffield Digital Festival on there as well. So I'm going to hand over to Ricky now, who's going to take you through the presentation and who will introduce you to the other colleagues in the room. Thank you.
Thanks, Chloe. Hello, welcome everyone. Thanks for joining us. It's been great to see some of the other presentations at Sheffield Digital Festival this year. Perhaps not quite the digital festival that people first envisaged, but it's great that people are still trying and put themselves out there. Before we start the presentation, then just some very quick introductions. So I'm Ricky Bearfield. I'm the lead engineer for our Sheffield office.
Hi, I'm Richard Pickering. I'm a tech lead and I specialise in Java and Go.
Hello, I'm Joshua Bates. I'm a tech lead specialising in UI development.
Hi, I'm Adam Carlos. I'm a software engineer, mainly specialising in backend and Java tech.
Okay, thank you. So, so migrating to microservices, a fork in the road. And as Chloe said, please post questions. We'll cover them as we're going along if we can. Otherwise, and more likely, we'll pick them up towards the end. Okay, so bit of background on BGFS for those of you that don't know us. We were established 27 years ago in Leeds, above a shop. And fast forward 27 years and we have 1,500-ish members of staff across various offices: New York, Melbourne, Lisbon, Houston, and 10 cities in the UK. And I'm very pleased to say as of last year, that includes Sheffield. So, we've been working in Sheffield for the best part of 10 years, but established the office last year. We are a delivery-focused IT consultancy working in sectors including finance, health and social care, public sector, retail, commodities and utilities, so cover quite a bit of ground. But today we wanted to talk to you, about Sterling Cutlery. So we're going to base the presentation on a little bit of a fictitious case study. If this bears any resemblances to anyone in Sheffield, then it's not intended. So Sterling Cutlery is a very proud company with a very proud legacy, established a long time ago in 1958, and it's really gone from strength to strength over that time. They've moved with the times, they've moved with the market. They started off just supplying Sheffield, and as things have gone more national, they've really embraced the mail order world, and they've supplied nationally, and they've started to get some international customers as well. They've really prided themselves on how quickly they can respond to their users or their customers and adapt. They introduced a new design product a little while ago where you can design your own cutlery service. This at the time was pretty unique. They were ahead of their competitors. They got it to market quickly. And they really understand that the world they're now in, that they're not just operating furnaces, they're also operating a large IT estate in order to cut their costs and to get things to their customers of high quality and on time. Their IT services are well integrated. When a customer presses order on their site after designing their cutlery set, their manufacturing process kicks in automatically. They're ordering materials from their third parties and their IT systems. It's an impressive legacy IT system they have there. It's done the job for some time. It's done the job really well. But alas, it's not all quite high fives and unicorns, let's say. Things have got a little bit more challenging in recent times. It's a well integrated system, but things are starting to show the time that the integrations have been in. The design your own cutlery set was a little rushed in truth, and it tends to be associated with some of the high running costs they're seeing now. The engineers are talking about no-go areas in the code, things that they're very reluctant to change, and as a result, they're kind of building on top of it, and not really maintaining properly that code base. Deadlines are starting to be missed. The businesses is really starting to notice now, and the systems occasionally start to fall over. And in their view, one of the worst things about this is sometimes it's their customers that are telling them, and their very proud reputation is starting to take a bit of a dent. Their staff themselves, the morale is beginning to lower. They're seeing staff retention go down a little, and perhaps a larger weighting in the number of junior engineers they have. They did have a bit of an experiment with microservices back in 2014, but nothing ever quite went live. So what they're finding is that amongst their engineers, microservices are being discussed. It's the word on everyone's lips. So a bit of a recap on what's perhaps driving that. From a business point of view, there's a slow delivery now. We're missing deadlines, which is something we're not used to, but it's becoming more commonplace. The morale is lower, and there's some damaging silos that seem to be forming. It's something they didn't really consider in the business before. Everyone seemed happy. Everyone was communicating well. It was very natural, but we're starting to see a little bit of contention between different technical areas. Staff retention, as mentioned, deployments are difficult. We heard people talking about weeks of hell for deployments now, rather than a nice tidy go live. Software changes are unpredictable. Production costs are high, and customers are finding out about things which they're worried is denting their reputation.
So let's take a step back. When discussing microservices, we should also consider the alternative. The polar opposite of a microservice is generally considered to be a monolith. So what is a monolith? Is it this? Clear, clean, precise, and perfectly purposed for a specific goal? Or are we talking more about this? This is a real place doing real work, but it's become difficult to keep working in the same building in the modern world. The organization wants to improve things, but this place has to keep working at the same time. It's got missing things. There's certain fundamental aspects to this building which are not efficient in a modern time. A monolith is a pattern in which all the code is deployed together. Using this model, features cannot be deployed independently. Any changes in this system are deployed together. So, on the opposite side of it, what is a microservice? As we can see on the left, a microservice has a much smaller level of granularity than a monolith. A system is provided as a series of smaller pieces, each piece providing logic that contributes toward the whole. As you can see on the right, a microservice is aligned to the business domain. It's not uncommon to have an account service or an order service. Some other things that we can see that they are as well is that they're small and focused. The real question is, how do we know if a microservice is small enough? So they're small enough to enable fast development throughput, but no smaller. In terms of considering if we can tell if they're small enough or not, the real question is, does it feel like it's too large? Effectively, if you feel that you cannot break it down anymore effectively, without the pieces being effectively too small, as in effectively having extremely small services, then it's probably small enough. If it's got too many split responsibilities and models, which models many business domains, it's probably too large. The size of a microservice is really key to both its advantages and its disadvantages. The smaller a service, the more moving components, but also increased development and deployment independence. Microservices are also autonomous. Some details are exposed to the outside of the service and others are kept hidden within. This allows consumers to couple to the contract the service exposes and remain unaware of the internal operational details of the service. You can compose microservices together to provide brand new functionality. So, tech follows communication. Communications on a software project can be really complex, and missed opportunities to communicate can translate to a lower level of software quality. Conway's law states, any organization that designs a system, defined broadly, will produce a design whose structure is a copy of the organization's communication structure. Microsoft conducted an empirical study into how its organizational structure affected the quality of Windows Vista. After investigating multiple metrics, including code complexity, cyclomatic complexity, these sorts of things, they found that metrics actually around the organizational structure of Microsoft itself and the departments that contributed toward those components were actually more statistically relevant than those other metrics. So, in terms of the benefits of microservices, we now know how communication can affect software quality and delivery. How do microservices help us in that way? Microservices allow us to make small iterative changes to large complex applications, allowing us to get those changes into the hands of our customers faster. Due to their loose coupling and use of structured stable APIs, microservices can be independently deployed. What if you experience a sudden surge in demand? Microservices can be independently scaled, allowing your software to keep up with the pace of consumer demand. And if demand falls back to normal levels, a microservices architecture can allow you to lower your resource consumption back to normal levels. Another great advantage of microservices is that they're actually tech agnostic. So effectively, you could have one service which may need to deal with a large number of concurrent requests written in Go, and it could consume data from another service which is actually written in Rust. Microservices communicate with each other using network requests. Each service can have more than one active instances at any one time. So that makes microservices a distributed system. That is, a system which involves multiple computers to process transactions. More moving parts can introduce complexity and a potential for race conditions as each instance of the application has to deal with concurrency. CAP theorem states, in the event of network partitioning, i.e. when you lose network connectivity between nodes, we must choose between consistency, i.e. when data is read, only the latest data written being returned back to the client, and availability, i.e. being able to access the service itself. Now, this has some implications really for the actual software service itself and its client, effectively, in which if a transaction effectively is taking part while we're experiencing these this loss of network connectivity between nodes, then we really have to consider, okay, do we have to cancel this transaction, or and effectively ensure consistency, or do we process the transaction and effectively lose the consistency, but effectively provide a higher level of availability? I mean, there's fault tolerance implications too. The caller really needs to handle the failure case where a downstream service is unavailable. Maybe it's rejecting connections, or it could even have accepted the connection, but it might be unresponsive. This has implications for logging in the system too. You have to be able to correlate log messages which affect a transaction across a whole range of different software services for that one transaction. So microservice systems must also be monitored appropriately, really. The successes, failures, and durations of requests going through the various microservices in the system itself really is, as there are more computers involved in the architecture, we need to carefully keep watch for any failures. A long delay on a downstream service can actually cause upstream services to experience even more prolonged delays. The linking of the services in this way can cause a delay in response to the client that originated the request. So effectively, teams using a microservices architecture do become deeply focused on the delivery of features within their specific problem domain. and also the ongoing maintenance and quality really as well. This makes the microservices architecture ideal for a cross-functional team approach. Having QA, operations, and development in a single team ensures that the team are enabled to work on the entire lifecycle of the application, and enables an extra level of ownership for that team too. In addition, the use for cross-functional team allows for the inclusion of different disciplines into the design of the solution. Involving IT operations helps refine what is required to successfully support the application in production, and the steps required to successfully deploy it. Involving QA helps refine how testing can be added at each step of the process effectively, rather than effectively handing over a large number of features across to testing in order to determine how to test it really.
So cross-cutting features. In a microservice architecture, changes become simple, teams become empowered. The team's change can fall into the domain for which they are often responsible. If we need to extend the catalog, the team responsible for the catalog domain must simply update the software, services associated with that domain. But using a microservice architecture, certain types of changes can become a little bit more difficult. As the architecture is split according to the business domains within the organization, a large shift in the organization's model can cause multiple services to require a change. Let's consider a new feature for Sterling Cutlery, selling your pre-owned cutlery back for recycling. This change would require a change to the account service, as now users can also be sellers. It would require a change to the orders service to allow sellers to send their items back to the cutlery. And also, another change would be required to the payment service to support paying the seller for the cutlery. If separate teams were undertaking the development and maintenance of these services, then this would require significant cross-team collaboration and coordination. In Solid, the open close principle specifies to make a module of code open to extension, but closed to modification. However, we cannot always predict every way we need to extend our services. If we were to try and cover every edge case, the resulting solution would demonstrate an over-proliferation of abstraction and also premature abstractions as well. Testing can also be really troublesome with microservices. A change in a monolith typically may require you to make the change, test it in a pipeline, push it through your environments. But for microservices, a sweeping change like what we saw in the previous slide naturally increases the amount of testing required and the infrastructure and pipelines required to support it. One reason we now need to test is that there's more fault lines across the code. How does the system handle the catalog service suddenly disappearing behind the scenes? Is there a UI? What happens to that UI? It's a little clear what might happen with the monolith, whereas now we've got all these additional areas to handle in code and test against. Another bit we should be wary about is side effects and chain reactions between the services. One thing going wrong, it could cause you issues elsewhere in the system. Just because you've got smaller services now, it doesn't mean you can make a change and test them in isolation. You may have a UI get some information from the order service, which needs to be fed into a follow-up request later on. If these new request properties are added, we need to ensure that the UI can still interact with the other services correctly. These are additional areas of resilience that you might not necessarily expect to test with a monolith, but now you really have to consider them with the smaller service spread.
Okay, so Richard described some of the great benefits of microservices and some benefits that may well be really useful for Sterling Cutlery. But I think we need to consider how many of those we really need on day one. And I think that's one of the themes for this presentation is really just considering the benefits against the cons, because Josh and Richard, in fact, described also a whole host of challenges brought about by microservices. So how many of the benefits will you need on day one, but how many of the challenges do you want on day one? It's not that all the challenges aren't things we can solve. All of the challenges are solved problems, but solving them brings complexity. So sometimes that complexity is an increase in processes in your organization, maybe an increase in the need of skills. Sometimes the complexity is new technologies like, say, Kubernetes and a service mesh of some sort. And don't get me wrong, all these technologies are absolutely brilliant, but they do introduce complexity. So perhaps we're asking the wrong question, or perhaps we need to stop thinking about this big migration and start thinking with a little bit more agility. perhaps we stop thinking about migrating our monolith to microservices and start thinking about improving our systems and leveraging a microservice architecture where it brings benefit. So what should our first step be? Well, we've got to remember that microservices are not going to be the goal. Our customers are not screaming out for microservices. You know, Sterling Cutlery's customers are screaming out for the latest and best cutlery, right? I presume. They're not sat at home going, oh, I just wish that the back end was based on microservices. So that's just not the case. So whatever we do, we need to keep the business in mind, and we need to work as a technical area of the company with the business, hand in hand. We need to continue to deliver business value and not go away and re-architect something for 2 years without delivering new value. The alternative to what I'm saying is obviously that big bang, that rewrite. And in our experience, they're rarely feature complete. You know, you've got to think that whilst you're getting to your MVP, whilst your rewrite is, you know, trying to get to where your MVP was, where your legacy product was, that legacy product is still evolving. You know, you're still delivering value to your customers. So it's not only a challenging target to get your new architected code base to your legacy product, but it's also a moving target, and that's really tough. So we need to embrace the intermediate state. We need to embrace this as an agile process and as an agile transition. Unfortunately, the flip side to that, if we are going to embrace the fact that we're not going from a clear A to a clear B, then we need to appreciate that middle part actually brings its own complexities. We've got to consider that the UI. So if we've got a slice of our system now in a new architecture, what's our UI going to do? Is this still a single customer experience? Is our UI going to remain coherent? How is technically we're going to get from page to page in our UI? They're all challenges we've got to solve. But probably the biggest challenge of all is the data consistency. If we've migrated some of our monoliths or some of our legacy systems, how are we going to keep the data in step? Can we actually think about that first slice by simplifying things so we don't necessarily have to keep all the data in sync, or it can be one way? And the other possibility is that when we're architecting our target state, we actually bear in mind that the intermediate, so perhaps an event-driven integration between our microservices might give us the opportunity to use those events to keep our existing legacy system in step.
So given what Ricky's just been talking about with the, we're going to be needing intermediate states here. We're going to end up probably with some kind of hybrid as we go forwards. What Richard and Josh were talking about with the benefits, the pros and the cons of microservices. If we apply this to Sterling Cutlery, how are they taking all of this on board? We can say that from looking at the way they've considered how microservices may be appropriate, the first step was to look at the businesses as across the context of how their systems fit into their business. Where are the boundaries, specifically sort of the business interfaces for things like where the customers are, the logistics, financial reporting, getting all of that, getting a deeper understanding of that. And although that kind of work would be necessary, whatever kind of migration, whatever kind of way forward they were looking for, specifically in this case, they were keeping an eye out, looking deeply for where the fracture lines, the fault lines could be, where a microservice would be appropriate, where they looking for an opportunity for a candidate first microservice. And luckily that worked with the business. One of the, as we talked about earlier, the design your own set, there was an opportunity there to white label that so that a high-end department store could use that and start adding their own branding onto it, which it may have seemed odd to pull that piece as their first candidate, but part of the side effect of it being a worrying part of the system was it had almost started to grow its own shell around it as people had tried to insulate their bit of the system from this bit of the system. So it actually became a good candidate and easier to extract. So they decided this would be the right way to go. This worked well for the business. They decided that, yeah, we can do this. We can put a team together to pull this piece of the functionality out. So put that team together, spin it up as a microservice. You've got 4 weeks to put something together. Show us how it will work. the team themselves, they're bought into this. It's the right way to go. We can do this. Well aware that there's going to be eyes on them. They are the ambassadors for microservices, or maybe guinea pigs. So they've set up. They're going to have regular planning sessions. The idea is to be open about what we're doing, what roadblocks we hit, where we see the benefits. And architecturally, if we look at sort of what their overall plan is here, it is keep the monolith we've already got, the existing service system stays up and running. We can pull this bit out. We can integrate the UI. We'll build a new UI, but integrate it with the existing one. Put this service together. You see, we're sticking with a relational database. We're not taking on too much risk here. We know how these pieces work. We're not going to try and switch to completely new tech. We're just taking one thing, pulling it out. It's a first step. We don't need to jump all of the tools, all of the microservice tools straight away. We can stick, as we see here, relational database. We can stick with that. We know how those work. Stick with the same languages, the same libraries that we already know. We don't need to try and switch cloud providers. We can stick with the one that we've got. So we're not jumping to Lambdas or any of the cleverest bits of Azure just yet. We don't need Kubernetes, Console, Istio, all of these orchestration tools straight away. We've got one microservice, we're standing it up. One of the things that was key to this is writing down all of these decisions that we made, where we make architectural decisions, design decisions, write those down. The reason for this is it turns over time into a logbook that can be referred back to both within the team. Why did we make this decision? And also across the teams. If you made this decision, did it work for you? Why did it work? Why did you choose to use RDS rather than have your own MariaDB? This is the key word there, was that this is the journey and they're starting to build the logbook, and they don't have to jump full rewrite everything across. We can build one piece, get it working, and then build on that expertise as this team gains the expertise. So as a longer journey, the way Sterling Cutlery is moving forwards is they agreed, okay, we're going to have these, this is a journey. We're going to have monthly migration planning sessions. As this service goes live, we're going to get it working, build the expertise, and that what's next, we can start looking for the next slice. It may be that the next step is not always tear the next piece out, get the carving knife out, carve out the next slice. Maybe we've got to improve a part of the existing system first. We may have to put a new interface on our existing system, tidy it up, basically prepare it to be sliced out. And over time, there's that works. The migration will ebb and flow between pulling out a new piece as a service and improving the existing service before we can pull it out. Amazon's idea of you built it, you run it, they're going for this one. So the teams own and run their own services. It may not always be the right choice, but it does give them a good scope for learning and changing things fast. They have the autonomy and the skills within the team to make the changes they know they need to make. Along with that goes the idea of the metrics. You've got to monitor what you're looking at, and there is masses of scope for the different metrics you can put on the case. In fact, you can pretty much end up drowning in your metrics and not knowing what you're monitoring. So the key part for them was to say what is important to us. What other than the most basic, are the services still up? What is the most important thing from the business? There's the metrics of, so in this case, they decided they wanted to know about the usage of the new service, who's using it, how many people are using it, and the order fulfillment times. So a very small number of metrics that gives the knowledge to the business of, is this working for us? And a few tech metrics that basically say, are we still afloat? Are things still working? More specifically on the technical side, they also put together a set of regular tech session meetings, the show and tells, the lessons learned, this kind of meeting, to try and get the knowledge outside. So this one team isn't going to be able to build all their microservices, as Richard mentioned. You tend to have a team owning the microservices they're building it. So these teams need to be able to share their knowledge, what worked, what didn't. They can share their logbooks, their key decisions, what does work for us. This also starts to help them understand. They can start to bring in the tooling as appropriate as they start to feel the creaking bits. They've suddenly got a certain number of microservices that maybe some kind of orchestration level will be appropriate. Maybe now is the time to start looking at switching, is a relational database no longer appropriate? Is a NoSQL Mongo, something like that, appropriate as they get to the next stage? But they don't need to take those decisions up front by regularly having their sharing sessions, regularly building on each other's knowledge. They can take those decisions at the time they need to be taken. Also, the business bought into the idea of automate. The more you can automate, the more you can grow. So that helps you. Also, if you can get to the point where everything's or as much as possible automated, you can start to build in resilience and trust in the architecture. If when something goes down, you can build it again, you can get back to a known state fast. That's a powerful way to build the idea that this is the right way to go forwards. So that is their way forward.
Thank you. Okay, so getting more towards a summary now. There's a couple of lists here, and I think they cover some, but not all, perhaps, of the things we've mentioned so far today. The benefits are you know, they're great things. They're going to make us more awesome as a business. Some of the things will make us deliver better. So our systems are, you know, less likely to have major outages. They can adapt to load better. They can scale better. Some of those things are about that. Some of those things are about allowing us to deliver faster as a business, to respond more quickly to our user needs. So, you know, the domain-oriented teams, where change is encapsulated in a team, we haven't got the communication boundaries. We're going to be able to get stuff out to our customers more quickly. But of course, we've got the red side as well, you know, and the challenges are also very real. And most of those benefits have at least, you know, costs in moving towards them, and also costs in maintaining them and running them. So there is a trade-off here. And not only are the challenges very real, but unfortunately they're pretty plentiful as well. So we've got to be careful that those challenges don't negate those business benefits of moving to a microservice world, and leave us in a worse position overall. So yeah, everything's a trade-off, and I think, you know, this isn't just a microservice. You could virtually have any discussion around tech or you know, or organizational changes, and you'll say it's a trade-off, right? But perhaps we shouldn't be thinking about moving to microservices in the same way that some of the really big players move to microservices. You know, perhaps you don't need 500 microservices. Perhaps that's not even an aim for a few years' time. Perhaps that's just unnecessary. Maybe we just need to take a few key parts out of our monolith where we really have the most business benefit to gain. Remember that migrating to microservices is definitely not just a technology thing. It might mean a bit of organizational shake-up. Remember Richard's comments on Conway's Law earlier. That stuff really, really matters. Don't throw agile principles out. We've got to iterate and choose user value. The business needs to be as big a part of this conversation as the technical leadership. You know, they'll be the ones to give you the idea of what that first thin slice can be. And hopefully we're solving a business problem, whether that's, you know, whether we're helping users because it's just not going to go down and lose their data anymore, or perhaps we're helping users because actually we're improving the functionality as we're slicing things off. I think the last bullet point I've got on there is something perhaps we haven't really mentioned today at all, but it's in our summary. This has been an architectural presentation. We're talking about moving to a different architecture. So let's make sure that that's the problem. You know, let's make sure that our architecture is the actual issue that we need to solve. A new architecture won't fix messy code bases. They're not going to address the cause of those messy code bases. So what we're going to end up with is messy microservices instead. And in you know, I think a lot of people would say it's a far worse state to have messy microservices than it was to have all your mess in one place. So, you know, let's just make sure it is an architectural problem that we need to solve in the first place. And in very final summary, I guess migrating to microservices, it perhaps doesn't need to be a fork in the road. Okay, so just very briefly, there's a few articles and books that we'd recommend having a look at if this topic is of you know, further interest to you. I'll leave that there for a second, but it will be on the recording if you'd like it. And finishing up, just to say thank you very much. We're going to take questions now. But if that's interesting, hopefully that's given you another perspective. If it's interesting and you'd like to, understand a bit more and a bit more about how BGSS could perhaps help, then there's a link there. From there, you'll find a way to contact us. But yeah, thanks very much for your time. Now we'll take questions.
I think we have a first question from Ben.
Yes, we do.
Yeah.
Okay, so just take a moment to read this. Okay. Just trying to understand the question. So there's some sort of more black box services, and there's sort of a different opinions on sometimes some people are saying it's okay for them to be black box services. We don't really need to be under the hood of them, and perhaps most wasn't the reason for failed pipelines or errors exposed in production environment. Is it purely overcome by strong documentation and fully mature QA processes? I think potentially, it's a little hard to consume the question live, but I think potentially what I'd say on this one is that perhaps there's a size issue. So microservices, and I think one of the challenges of microservices is not to spend too long talking about how big microservices need to be. But in this case, if a microservice is hard to understand as a black box for other teams and to support, etc., then potentially it's a little bit big. Perhaps its interface is a little bit large. Perhaps individually it's getting a little bit too much airtime. I think, yeah, in terms of failed pipelines and so forth, you're going to be under the covers of a microservices if you're dealing with the pipelines, because it's the same team that's producing those pipelines and enabling it, that it's writing the microservice. Ideally, we are talking about cross-functional teams here, and this perhaps could get us into a discussion around DevOps and the culture of DevOps more than the team of DevOps. DevOps has never meant that ops isn't needed. It just becomes much more of an enabler. So I think I don't quite know if I'm answering the question, but I think what I'd say here is size as a microservices should be small enough that people can understand it, and in the way that when people do need to be undercover, they probably should be part of that team.
I think I might be able to help answer some of the questions as well, at least one aspect of it. Just from past experience, we found versioning the interfaces for your microservices did help. If you were going for the full-blown approach, the idea is you can run multiple versions, so different microservices can declare which version of another microservice they want. But even going for the simplest version, as long as you're checking which version, so as you as the client asks for version 2 of your provider, if version 2 doesn't exist anymore because they've upgraded it and hence changed the interface, at least you blow up fast. So during testing, you find out that the interface changed because the version number doesn't match, rather than finding out when you're in production that something has subtly changed in how the data is used. So it's sort of a fail fast. You can use the versioning just as a fail fast mechanism, rather than necessarily running multiple versions in live at once. I don't know if that helps with any of that aspect. Also, if it helps, Swagger docs, so auto-generated API documentation often helps. You probably don't want to publish them publicly, but internally Swagger docs can help quite a lot.
Okay, well, it looks like that's the only question. So I'll say thank you again, and I hope you all enjoy the rest of Sheffield Digital Festival. Hand back over to Chloe.
Thank you, Ricky. Thank you very much for attending, everyone. Like Ricky said, if you go to bgss.com/Sheffield, you'll find the recording of this later on if you want to watch back or if you want to hand on to anyone. And please check out any of the events going on for kind of the next 2 days on there as well. Thank you very much.